So when we graph these radicals, we can always start with our parent graph. And I'm a big fan of putting the parent graph no matter what, which is 0, 0, 1, 1, 4, 2, and 9, 3. Now what's nice here is when there's no A term, okay, the shift is really just from the vertex. So we're going to shift every point left 5, down 3. So from here I'm going 1, 2, 3, 4, 5, down 3. Different color there. 1, 2, 3, 4, 5, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, and 3. There's my graph. Okay. If you prefer your other option, what makes the radical equal to 0? -5, which gives me a -3. -4, square root of 1 is 1. 1 minus 3 is -2. -1, square root of 4 is 2. 2 minus 3 is -1. And finally, 4. And 4 plus 5 is 9. Square root of 9 is 3. 3 minus 3 is 0. And then you can plot the points that way as well. Second one, 0, 0, 1, 1, 4, 2, 9, 3. If I do have an A term, I multiply the Y coordinate by the A term. This becomes 0, 0, up in there. But 1, 1 becomes 1, 3. 4, 2 becomes 4, 6. 9, 3 becomes 9, 9. And that's where our shift is now coming from. I'm going left 1, down 6. 1, 2, 3, 4, 5, 6. Left 1, down 6. 1, 2, 3, 4, 5, 6. Left 1, down 6. Left 1, 1, 2, 3, 4, 5, 6. Left 1, down 6. 1, 2, 3, 4, 5, 6. And there's my graph. And if I wanted to check my work, okay, if I wanted to check my work, you can plug a point in, like 8, 3. 8 plus 1 is 9, the square root of 9 is 3, 3 times 3 is 9, and 9 minus 6 is 3. If you want to do the chart, so whatever makes the radical equal to 0 is what we start with. -1, 0, 3, and 8. And you want to pick numbers that give you a perfect square. -1 plus 1 is 0, times 3 is 0, -6. 0 plus 1 is 1, square root of 1 is 1. 3 times 1 is 3, and 3 minus 6 is -3. 3 plus 1 is 4, square root of 4 is 2, 2 times 3 is 6, 6 minus 6 is 0, 8 plus 1 is 9, square root of 9 is 3, 3 times 3 is 9, minus 6 is 3. I'm going to draw the parent graph, 0, 0, 1, 1, 4, 2, and 9, 3. And now if I do a shift, each of these Y terms, we multiply of the point, we multiply the Y coordinate by the A term exactly. So now we're going from 1, -2. Now I'm going from 2, -4. And now I'm going from 9, -6. I'm watching people make that the parent graph. That's not the parent graph. So I'm not a huge fan of this being drawn in. I'm fine with you putting points down. Don't draw that in as your parent graph. Your parent graph is this. Now the shift from those 4 points, left 1, up 8. So on these, with the x minus 1 there, we should be going right 1, up 8. Right 1, up 8, 1, 2, 3, 4, 5, 6, 7, 8. Right 1, up 8, 1, 2, 3, 4, 5, 6, 7, 8. And then right 1, up 8, 1, 2, 3, 4, 5, 6, 7, 8. And that should be my graph. Well done. So if I wanted to check a point, 10, 2 should work. 10 minus 1 is 9. The square root of 9 is 3. 3 times negative 2 is negative 6. Plus 8 is a positive 2, and I'm there. If I wanted to put a chart in, we're going to start with 1. And if I have 1 there, I'm going to get 8. If I put 2 in, I'm going to get 6. If I put 5 in, I'm going to get 4. And if I put 10 in, I'm going to get 2. Now down here with the half, this is always a little harder to graph. You do the best you can though. The expectation is you can graph a fraction. I'm going to start with my parent graph with all those same basic points of 0, 0, 1, 1, 4, 2, and 9, 3. And now each y coordinate gets multiplied by a half. So here it's still 0, 0. 1 half times 1 is 1 half. 1 half times 2 is 1. And 1 half times 3 is 1.5. Or 1 and 1 half. Here, so from here, all right, we're going to go left 3, 1, 2, 3, down 2. Left, 1, 2, 3, down 2. It puts me in the middle. Left, 1, 2, 3, down, 1, 2, 3, down 2. And left, 1, 2, 3, down 2. And yeah, I don't expect your points to be perfect. But they've got to be in the general vicinity. And if you want to check one, I would check an exact point. I would check 1, negative 1 to see if that works. 1 plus 3 is 4. The square root of 4 is 2. 2 times 1 half is 1. 1 minus 2 is a negative 1. That does work. If you want to work with a chart, you're going to have to deal with a fraction now. Negative 3, negative 2, 1, and 6. The radical is 0, we're left with negative 2. If the radical is 1, 1 half minus 2 is negative negative 1 and 1 half, negative 3 over 2, negative 1.5, however you want to write it. 1 plus 3 is 4. The square root of 4 is 2. 2 times 1 half is 1. Minus 2 is a negative 1. And finally, 6 plus 3 is 9. The square root of 9 is 3. 3 times 1 half is 3 halves. 3 halves minus 2 is negative 1 half. You can start to see the pattern there as well. When we have a weird fractional exponent like that, the key is getting that fractional exponent to be 1. I'm raising both sides to the 4/5. You raise to the reciprocal, which leaves you with 2x plus 10 equals the 4th, or 32 to the 4th, 32 to the 4/5. That is essentially, we'll do it over here, the 5th root of 32 to the 4th power. What is the 5th root of 32? 2. What is 2 to the 4th? 16. So it's simply 2x plus 10 equals 16. 2x equals 6, and my x equals 3. 2 times 3 is 6. 6 plus 10 is 16. The 4th root of 16 is 2. 2 to the 5th is 32. When you plug it back in, it should work. Then we agree here that to get rid of the stuff around the parentheses, for lack of a better term, We subtract 2 on both sides. 3 times 10x minus 3 to the 2/3 equals 81. And then I divide 3 on both sides. So we get 10x minus 3 to the 2/3 equals 27. Okay. Now, what do I do next? We're raising both sides to the 3/2. Now, we're left with 10x minus 3 equals 27 to the 3/2. If you can't take 27 and turn it into an exact number, like it doesn't work out, you don't have the square root of 27, okay, what we're going to do is this. It's the square root, and you don't even need the square there. Actually, I shouldn't even write the square there. It's simply this. The square root of 27 cubed. So my answer is going to look as such. Just scroll down here a bit. 10x equals 3 plus the square root of 27x cubed, or I'm sorry, 27 cubed, excuse me. And my answer is this. Now we have the radical, which is really just a parenthesis raised to the 1/2. I'm subtracting 7. 2 to the times 3x minus 5 equals 8. Divide everything by 2. Square root of 3x minus 5 equals 4. We get rid of a radical by squaring it. 3x minus 5 equals 16. We add 5 to both sides. This is basic algebra 1 now. And x equals 7. And plug it in. 3 times 7 is 21, minus 5 is 16. The square root of 16 is 4. 4 times 2 is 8, and 8 plus 7 is 15. With the cube root, it's the same deal. You still got to get the radical alone. The one difference in this problem is I'm not squaring both sides. I am cubing both sides. That's how I get rid of the radical. 4x plus 3 equals 27. We subtract 3 on both sides, and 4x equals 24. We divide by 4, and my x equals 6. You plug that back in. 4 times 6 is 24, plus 3 is 27. The cube root of 27 is 3. 3 times 4 is 12. 12 minus 5 is 7. In both problems, we're literally getting the radical alone. And then we were raising it to the index. On the left side, it's squared. On the right side, it is cubed.